Oh, hello. You've just caught me as I'm about to start planning this sixth form chemistry lesson. So let me talk you through my thinking. Okay, we're talking about thermodynamics, which really means does a reaction happen from an energy perspective, if you like. So thinking ahead, what will they be doing about this later on? Eventually they'll be learning about this equation, which kind of tells them at a given temperature, does a reaction happen or not? If this number here turns out to be 0 or below, it will be feasible. So they're going to learn about the entropy later on, and right now we're kind of thinking about all the different ways in which they can be asked about this thing, delta H, which is the enthalpy. So really we're thinking about this in this particular lesson. So I'm going to have a quick look at exam papers and just see the type of things that they'll be asked about this. So I'm looking at the most recent iteration of paper 1 chemistry here. Question 5, here we go. This is the type of thing that they'll have to do, something called the Born-Haber cycle, and they'll have to fill it in and then calculate some numbers based on it. Here, for example, it's worth 4 marks. That's out of 300 across all 3 papers. So it's quite a lot of the entire A-level mark. So what I'm going to do is I think I'm going to use this as my consolidation. I think if I get them to do this exam question, it will be a nice consolidation task. So I'm just going to chuck that in at the end here. So I've got the 2023 paper 1 and we're looking at question 5.4. They're going to do that as their consolidation, okay? Great, so working back now, what I'm going to do is think about the demonstration phase, if you like, and how am I going to set my students up to be able to not just do this, but kind of smash it out of the park a little bit. So in my demonstration, here's where I'm going to build in a little bit of kind of differentiation and thinking about how I can really challenge every single student. So as I'm working between my consolidation and my demonstration, really I'm thinking about challenge, right? And here's where I want to kind of, as I said, target and challenge every single student. So really, when we're introducing challenge, we are manipulating this kind of relationship. So challenge is kind of proportional to task complexity divided by what you would say is support. So in this part here, I'm looking to manipulate this little equation and vary the amount of challenge that I give to all my students. Let's start by thinking about the kind of top end, my kind of AA star students. So really what I'm looking to do here is I'm looking to kind of diminish the support, but really kind of ratchet up the complexity based on what they'll be doing in the consolidation task. Really what I'm thinking of doing here is like overtraining them in this stage, so that when they see this real exam question, they'll just be able to walk over it really, really quickly. So I'm going to give them something quite tricky here. I'm going to give them something which is harder than this. This was a question about calcium chloride. So I'm going to choose a harder compound, so I'm going to choose aluminium oxide. And you can see in the exam question, they get sort of elements of support in the Born-Haber cycle. I'm going to remove that. And I'm going to say you're going to do aluminium oxide and you're going to do it yourself. Next, I'm thinking about my kind of B, in or around a B student, maybe looking to push towards an A, or maybe just kind of consolidating this B. They're going to be doing something quite similar, I feel, maybe a little bit harder than the CACL2, because it's a little bit easy. So I want them to just get a feeling if this question is a little bit harder than this. Maybe NaCl. I won't explain why that's harder, but it just is, and trust me on that. And I'll give them a little bit of support. So again, I'm playing around with the complexity and the support here. No longer doing it themselves. I'm going to give you 2 lines of support. And then finally, I've got my kind of students that I'm looking to push towards a B. Maybe they're currently on this kind of CD sort of level. They're going to get something which is similar in a level of challenge to this. So calcium chloride, I'm going to give them magnesium chloride, very, very similar. And I'm going to give them maybe a little bit extra support than the kind of B guys. So maybe like 3 lines worth of support. And let's see how we do with that. So there we go. That's my kind of demonstration bit in here. Okay, so now I'm going to work backwards from my demonstration and think about my activation. Really what I'm doing here is thinking quite hard about what type of what type of skills, knowledge are required to do this task. Really, when I think about this, it's quite heavily process driven. So because there is lots of process involved, I'm definitely going to look at giving them a worked example. And in my worked example, I'm going to be really, really conscious of lots of different things, lots of little misconceptions and so on, which I want them to be aware of. To give you a couple of ideas around this, I know that, for example, they're going to get stuck with the idea of atomization, right? So when we atomize something, we are going from, could be going from like a molecule in the gas phase to atoms in the gas phase. So O2 gas goes to 2 oxygen in the gas phase. That's hard for them to pick up. Also, what's hard for them to pick up is this idea that this is actually 2 times delta H atomization of oxygen. So I'm really going to kind of take care and go slow over that in my worked example, and maybe use something like mini whiteboards to make sure that we're kind of on the right track, question it quite significantly. Another idea that I think is worth building into my worked example is this idea of electron affinity. So really, when we look to add electrons to my oxygen, initially it's a negative enthalpy change because it's favourable. Adding electrons is favourable in this case. But then we want to add another mole of electrons to my oxygen. When I do my second electron affinity, so that's the first EA, the second electron affinity, when I'm adding electrons to this, to the O minus, that's now going to be a positive change because you're trying to add negative electrons to something which is already negative. So there's a big repulsion, so that's going to be positive. So I want to really make sure that my students are aware of that in my worked example. So again, I'll be thinking about how am I going to be really explicit about that, how am I going to maybe cold call it a little bit, or maybe again use mini whiteboards. Probably going to lean towards mini whiteboards because I want to make sure that everybody gets it. This is kind of already getting me thinking about what I'm going to use in my worked example. Because of this idea of needing a second electron affinity example, I think I'm going to use oxygen, and I think I'm going to use something where we form an oxygen ion. So maybe what I'll do is use magnesium oxide, MgO, in my worked example. It isn't just process driven, it's also quite knowledge driven. So if I kind of look at the textbook and think about, okay, what kind of knowledge does the textbook kind of say that student wants? It's just like a double page spread of definitions, endless, boring definitions. And, you know, as much as I don't like my students, I don't really want to give them that. What I want to do is for them to be able to kind of hook their definitions onto something a little bit more cognitively bearable. So, the second part of this now, the knowledge bit, this is going to kind of really bleed into my activation. How am I going to be able to activate them to get the knowledge about all these definitions, then put it into a worked example as we go into our demonstration and finally consolidate it. So for my activation ACT, what I'm going to do here is I'm going to give them some pictures effectively, which will help them build up a better understanding of what each of these definitions is. Give you an example, so really kind of simple. Okay, I'm thinking about atomizing a metal here. So I'm using just particle diagrams, which they will have seen across kind of key stage 3, key stage 4. And you know, I can use a bit of questioning around this, just really kind of quick, sharp stuff, right? I'm going to be telling them, right, okay, I've got 1 mole of a metal, let's just call it M for now, and I'll just be like, just teasing bits out of them, right? What state is this in? It's clearly a solid. Okay, and then I'm going to be thinking, right, I'm gonna keep my 1 mole. We're now going up to this image instead, where they're no longer in the solid phase, in the gas phase, so the particles are going to be further apart. Still got 1 mole, and it's still a metal. And you know, using this picture, it's a lot clearer for them to see that we've got, okay, you've got 1 mole of a metal going from the solid state to 1 mole of the metal in the gas state, and the definition for this is delta H atomization of this metal M. Great. And then I'm just going to kind of repeat that with all the different definitions that they need to know, all these different little enthalpy changes, and then we'll just have a much better picture of what each one is. It's not perfect because, you know, I've got 9, 10, 11, 12 atoms here and only 3 there. So I've just got to be careful and saying, you know, don't think about it in that way. I've got 1 mole here, I've got 1 mole there. It's always 1 mole in the picture. I'm understanding that it's not perfect, but also it is really good for kind of breaking it down for them in a cognitive kind of way. So before the activation, then I've also got to think about my do now. So with that in mind, what I'm going to do here is just prime them for all of this by looking at something from year 12. So here's what I had in mind to start with. Because I want to get them thinking about, I want them to basically kind of retrieve a skill which they've done in year 12, and what they're doing now is just doing it in a far more advanced level. So I want them to be doing that through this question. I also want them to be thinking about this idea of Hess's law, which is like this kind of overarching thing that they'll need for this. So this question is fine. I'm going to tweak it slightly because this is quite a closed question, and actually at A level, I tend to move away from that and maybe think about something more open. You kind of get a bit of differentiation by outcome, and as you circulate, you can really kind of see what your students are thinking. So what I'm going to do, instead of just giving it a closed question, work out the enthalpy change for this reaction, I'm going to say something along the lines of, tell me everything about this reaction, and let's see how they go on with that. Okay, so there we go. That's my approach to planning. Hope you find it useful.